Hi folks, this is a recording of my presentation for the Yocto Project Virtual Summit Europe, scheduled for October the 29th, 2020. I'm going to be giving you a demo of using Rust with Yocto Project. So Randy will have given a talk, more of a presentation style about this. I'm going to have a couple of slides and then I'm mostly going to spend my time on a demo for you, showing you how to actually use some of this stuff in practice. So first of all, a little bit about me. I've been involved with the Yocto project since around the middle of 2013, and since then I've worked across the embedded stack, bootloader, kernel, Yocto project and various other components along the way. These days I am working as a principal engineer at Consulco Group. We provide basically any sort of consulting around embedded Linux that you may require. We've got a lot of experience in all the areas I mentioned before. So some personal contact details if you want to follow up about any of this. I've got my email address there. I also have a personal website and a Twitter account. Feel free to follow up using any of those methods. So this talk, I'm going to give a brief introduction, and I'm going to keep it brief because most of the discussion about Rust is going to have been covered by Randy already. I'm then going to show a couple of details about the interaction between the Rust language support in Yocto project and our license compliance features. I'm going to show a couple of slides about how to actually get Rust installed on your development machine and why you might want to do that, and then I'm going to move into the demo. So diving straight over to license compliance. Like many newer programming languages, Rust has got its own package manager and build tool, and for Rust this tool is called Cargo. So this is similar to Node.js ecosystem built on top of JavaScript that's got the npm node package manager, and similar to the way Go has its own build tool as well. Now these tools often present issues for us in the embedded Linux world. The sorts of things we care about just don't seem to be first-class concerns sometimes to the developers of these tools. So, all the things we've put in place to handle, what we need when cross-compiling, what we need when building for a customized image to go on a target, and what we need to achieve license compliance. Those features sometimes aren't there. So what I did, I took a look at this and I made a list of all the features that, in my opinion, we need in order to be able to properly support working with one of these language package managers. And these are features that the language package manager itself needs to provide so that we can integrate with it well from Yocto project. So we need the ability to build offline. In Yocto we have a do fetch stage that's separate from the do compile stage where we actually build the software, and we want to make sure that separation is clean and we don't end up with additional elements being fetched during the do compile cycle. We want to be able to download sources in some sort of archival form, rather than just some kind of online build system. We need something that we can archive, keep long term, come back to years later, or provide to our customers as part of our license compliance. We need to be able to capture the license text and other collateral that goes with a project. So this may be, again, part of our license compliance activities. It may be scripts that are needed to rebuild the software, other things like that. We need to be able to capture these files as well. We need whatever tool the package manager uses to download sources to support HTTP or HTTPS proxy, as that's something we support in the Yocto project. And lastly, we need to be able to set up our own source mirror, which may be locally on the machine we're working on, or maybe some sort of internal server within a company. That we should be able to set that up and use that as the source for our downloads rather than going to some sort of official upstream all the time. That should be configurable. So looking at Rust in particular, Cargo, which is the build tool used by Rust, actually integrates really quite well, and all the features that I described in the previous slide that we need are supported by the way that Cargo is integrated into the Yocto project within the Meta Rust layer. The one limitation that I've found is that, you know, if you've got a project and it has some additional dependencies, the license and the license text will be captured for the project itself, but they will not be collected for all the dependencies of your project. So that is something that needs a bit of extra work, and at the minute I would say just be careful. Make sure that you're manually capturing that information for any of the dependencies that your Rust-based projects have when you're building them with Yocto project. So that's pretty much all I have on license compliance fairly briefly. The next thing I want to run through before I move over to my demo is just how to install Rust on your development machine. So installing Rust natively on the development machine is not a requirement of being able to build recipes which use Rust within Yocto project. But it is required if you want to run the Cargo bitbake tool, which I'll be demonstrating, which is used to auto-generate a recipe for a project written in Rust, and being able to build and run software natively can really help with debugging. So those two are kind of my reasons why I think it's important to install the Rust toolchain natively on your development machine. So the canonical way of installing Rust is to go to the rustup.rs website, and that will give you a couple of options. The straightforward way on a Linux system is this curl through shell pipeline here that just downloads the latest version of the setup script and runs that. It will ask you where you want to install Rust. It will set up the environment variables on the next login, but if you want to go straight ahead and use Cargo and Rust after you've installed them in the same terminal, you will need to source the environment file that is created. And if you want to use the Cargo bitbake tool, once you have Rust and Cargo installed, you can then run this Cargo install command at the bottom that will go and download the source for Cargo bitbake and build it. So those are kind of the prerequisites if you wanted to repeat what I've done in the demo. So yeah, there are a couple of tricks I'm just going to point out about my demo. These are just things to make it flow smoothly on the day. So I've got a pre-populated shared state cache. That means things are going to build very quickly. Don't expect them to build that quickly on your system. Things do. Rust toolchain itself, built within Yocto project, does take a little while to build. But yeah, for the purposes of getting a demo within the sort of 20-25 minutes that I'm going to have, yeah, pre-populated shared state cache is critical. I've also got local mirrors of the layers I'm using of Pocky, Meta OpenEmbedded, and Meta Rust. That's going to save time in my git clone step, and it's just a lazy way of making sure I get the same commits that I tested. And I'm running on Arch Linux on my build machine at the minute. Arch Linux isn't really a stable base for Yocto project builds, so I'm using Podman and the crops containers to run my builds on a stable distro. And all those things will become apparent as we go through my demo. I just wanted to kind of flag those things up front in case you want to replicate what I'm doing. So I'm going to pause for a minute here and then come back with my demo. So this is going to be the demo section of my presentation. I've got a Visual Studio Code window open, and this is connected to my Linux build machine. I'm actually running Windows on the desktop here for various reasons, but yeah, using the remote over SSH capability of Visual Studio Code, I can work pretty well. So the first thing I'm going to need is a terminal. Should surprise no one. And I have a project directory. So I'm going to make myself a new directory to work in, which is going to be called YP Summit 2020. And what I'm going to do is I'm going to reload my Visual Studio Code instance in this directory. So this just gives me a nice setup for using Visual Studio Code because I've set the root directory of my project. Right now it's looking pretty bare, so let's start bringing some things in. So the first thing we're going to need in order to demonstrate something with the Yocto project is our core layers themselves. So I have a mirror of the Pocky repository on my machine, as I mentioned earlier. I'm going to clone that, and I'm going to pick up the Dumfell branch. So this is pulled Pocky in here. I'm also going to pull in the Dumfell branch of Meta OpenEmbedded, as that's going to be a dependency of the Meta Rust layer. And I'm going to pull in Meta Rust itself, but Meta Rust does not have a Dumfell layer. Dumfell branch. Meta Rust doesn't have a Dumfell branch, so we're just going to pull in the master branch of that. So this gives us our three layers that we're going to be using today. And with these layers and a little bit of additional work, we should be able to show some Rust code being built with the Yocto project. So let's take a little step further. So looking in Pocky, one thing I'm going to want is the ability to build, run Yocto project builds. As I mentioned, I'm using Arch Linux on here, so I actually want to be running my builds within a container. So I'm using Podman as a container manager, and this is going to be the command to start my container. So I am running a container, I'm using -rm to remove it when I'm finished, I'm using -it to make it interactive and give it a terminal, and then I'm using -v to mount some volumes. I'm mounting the current working directory to /w, and I'm mounting this cache directory, which has my downloads directory and my state cache, to /cache within the container. And I'm using the Debian 10 crops container. So if I run this command, I should be dropped at a prompt in what looks like a Debian instance, which is good. So I think I'm in slightly the wrong place. I am going to redo that from the top level so that I can see the other directories I've created. So let's have a look in Pocky. So the first step, like we would with following the Yocto project quick start, is we're going to set up a build environment. This is pretty much an out-of-the-box Pocky setup. We're then going to add in the layers that we want to use. So we're going to use the BitBake layers tool This has a couple of useful commands. The ones I'm going to be using are add layer and create layer. So I'm going to use the add layer command to pull in a layer. So you give it a path to a layer directory, and it's going to modify your BB layers configuration for you, as well as just checking that, running a few sanity checks to make sure everything's happy. So I'm going to do that again to add the Rust layer into my build. And the last thing I'm going to do here for now is use BitBake layers create layer. So I'm going to be putting together some recipes for software that's written in Rust, and I'm going to want somewhere to store them. There's a few different ways of doing this. I'm going to create a layer from the start and just drop the files straight into the layer. So I'm going to create a layer 2 levels up, and this is going to be just called Meta YP Summit. So this has created a Meta YP Summit directory here on my system with conf file and some example recipes. It's also printed a message saying we can add our new layer with this bitbake layers command. So I'm going to pick that up and run that. So yeah, we've now got all the layers that we want added, and just to confirm what that looks like, let's move our terminal down out of the way. And yeah, we've got a few changes have been automatically made to our BB layers conf file to include these various layers. And to check that this is happy, we're going to build core image minimal. And this is just going to take a second to parse all the recipes in all these different layers. And then it's going to run a build, which hopefully, well, I've made a mistake. I realised straight away that I had made a mistake. This is the joys of doing a live demo. And of course, I've ran into a bit of a lockup here, which is not great at all. So what I'm going to do is I'm going to copy over my site configuration file. So within /cache I have a site.conf file. I'm going to bring that in. And this is just a simple file that says where to find my shared state caches, which are split by distro and version, and where to find my downloads directory. So with this in place, my build should run properly now. So this should actually be able to find my shared state cache mirror. So it's going to reparse everything. And yes, it's picking everything up from my shared state cache. So at this stage, I've added some additional layers in, as I say, but I've not really done anything with Rust itself. I'm just doing a bit of a sanity check to make sure that a simple build succeeds. And this really doesn't take very long at all, since everything is populated in the shared state cache. So now we're in a pretty good place, and we're going to also just quickly try out run QEMU. Since I'm in just a terminal here, I'm going to use no graphic, and since I'm in a container and I've not got access to some of the device nodes I might need for network tap, I'm going to use Slurp, which is the option for software networking. And this is going to boot my image that I've just built. And we can log into this. Now I'm just going to demonstrate two commands are absent. So there's a hello isn't found and print-rand isn't found. So these are the two utilities written in Rust that I will be implementing and adding to the image. So I just wanted to show, these are not in the base image when we start off. We can close down this image and we can start thinking about doing some things in Rust. So what we're going to need is a new terminal. So this terminal is inside our container that we're using for building. We're going to need something that is outside and is in my host system, because what I have in my host system is the cargo tool, which is the build and package management tool for Rust. Now cargo has some pretty useful commands. So one of those is cargo init, which is going to create me a new package. I'm going to create a package called hello-temp. It's temp because I'm going to be replacing it with a pre-built hello package in a couple of minutes. But for now I just want to show you what you get from cargo init. So it's going to create me a directory and populate it with a couple of files. It populates with a git ignore to ignore the target directory that is created when you build a thing in Rust, and it's going to populate a cargo.toml file. So this is the configuration file for cargo, contains the project metadata, and it's going to give us a source file, and this is what hello world looks like in Rust. It's pretty straightforward. It looks kind of similar to C if you squint hard enough. We've got a main function and we're using the printline macro to print the hello world string. And I'm just going to show you with this, if we cd into this directory, we can use cargo build to build the project in the current directory, and that builds fairly quick when it's just building a hello world program. And we can use cargo run just as a shortcut to run the binary that's been produced. And we see that this prints the string hello world. So I'm going to briefly pause there. So let's move on to the next step of my demo. We've got some code written in Rust. Let's look at how we bring that into Yocto Project and build it within our environment. Now the first thing that we need is this to be somewhere online that we can actually fetch. So this is why I've created a hello-temp. What I'm going to do instead is git clone a thing I made earlier. So up on gitlab.com, under my user, I have a Rust hello application. This is similar to the hello I already did, but with just a couple of changes. So I added a license file, I added a readme file, and I added a couple of lines to the project metadata. I added the license entry, I gave it a description, and I added a line pointing at the repository. So this is kind of what you'd expect a project to look like once it's been published somewhere. So if we step into this hello directory, we can use the cargo bitbake command that I discussed earlier to generate a bitbake recipe, and that drops a bitbake recipe in the current directory, and it looks fairly similar to a sort of bitbake recipe you'd see, but with a couple of differences because it's auto-generated. It's kind of based on a very verbose template. But yeah, we're going to use this cargo BB class that's going to contain all the instructions for building this with cargo. It sets the source URI pointing at the remote of my Git clone that I made. It sets source ref to the revision that I have checked out. Sets the S directory, a couple of other little bits. There's an empty addition to the source URI here, which will make more sense later. It's found our license file, captured the MD5 some of this. It's put the description that I gave in my cargo.toml file into the summary in the recipe. It's put the repository entry into the home page, and it's picked up the license entry. And the bottom of this file has a couple of include statements. These let you add additional lines to either of these style of .inc files in case you regenerate this recipe in the future for, say, an updated version of the software. You want your customizations to be in a file that isn't going to be regenerated. So we've got a recipe. Let's put it in a layer. So we created this meta YP summit layer to store our recipes in. So we're going to have recipes YP summit, and we're going to have a Rust folder, and we're going to move our hello recipe in here. Now this is nice as a simple recipe, but it's not got any dependencies. This is just very, very simple. So what we want to do is we want another project as well. It's just a single step more complicated. And we're just going to pull this one straight down from GitLab. Again, from my GitLab account, we have print rand. And this just prints a random number. It's really that simple. Print rand, looking at, again, it has license, has a README, has a cargo toml file, and it has some source written in Rust. We look at the cargo toml file first. The main difference here is that we have a dependency listed. We're using the rand crate, and we're specifying version 0.7 because this is not yet at a 1.0 version and the API might change. We're going to pin the version somewhat. Yeah, the rest of this looks pretty much as the other project configuration file did. The change in the source code itself, we're going to use this use statement to pull in parts of the rand crate that we need. We're just going to generate a random number by calling the random function, and then we're going to use the print line macro to print that number. So let's just take a look at that before we move on. So in our print rand directory, if we run cargo build, this is where it's going to be a little more interesting because it's going to build some dependencies. So you see it compiling the dependency crates, and then you see it compiling print rand itself. And then if we do cargo run, it's going to generate and print a random number that's going to be different every time we run it. So let's generate a recipe for this using cargo bitbake. And again, we have a recipe file that's been generated. This fairly similar to the previous one. The main difference is these source URI entries. So this is using the crate fetcher that gets added into bitbake in order to pull down the crates. We have not just the rand crate that we listed as a dependency, but we have all these other bits and pieces that are dependencies of that crate. So it's going to pull all of those down and use them to build our software. The rest of this looks the same as our Hello World recipe looked. So again, we're going to grab this, we're going to put it in our Rust directory within recipes YP Summit within our layer so that bitbake can find it. Now if we hop back over to this terminal, which is in our build environment, we can build both of these. We're going to build them both at once just to save some time. And this is going to pick things up from cache because I built them previously. But obviously, if you do this, it will take a little bit longer on your machine. It will first build the Rust toolchain from source, and then it will build the recipes that we listed. So that's looking pretty good. Things were successful. We're now going to want to test these things out. So we're going to want to add them into an image. So we're going to create ourselves a little image recipe just so that we can test this out. So we're going to create a folder for our images, and we're going to create a new file that is going to be YP Sonnet image. We are going to pull in recipes core images core image minimal. Require is like include, but it throws an error if the file is missing. Obviously we expect this file to be there, so that's, we want to catch that error if it ever is missing for some reason. We then want to add our recipes to image installs. We have a hello world and we have a print round. So this is a simple image recipe. Let's come back to our terminal and bitbake our new image. Hopefully this will work. Let's see if I type that out correctly. So again, it's pulling things from the S-state cache. And it's building an image. So that's pretty good progress. So yeah, this image is going to be like core image minimal, but it's going to have these two additional utilities that are implemented in Rust added into the image. So the last thing we're going to do is we're going to use run QEMU. And this will pick up the latest image that was built, which is going to be our YP Summit image. And hopefully this is going to have our utilities in it. So if we take a look, we log in, we have hello, which prints hello world, and we have print rand, which prints a random number that's different each time we run it. So we have successfully implemented some simple applications in Rust, one of which, hello, had no dependencies, one of which, print rand, had some dependencies. We've generated recipes for both of those elements using Cargo Bitbake. We have added them into an image recipe. We've built everything and we've tested out under QEMU. So yeah, that concludes everything which I wanted to demonstrate. So thank you very much for your time. I'm happy to answer any questions afterwards by probably discussion on Slack at this stage. So thanks very much for your time, folks.